Hi everyone, and welcome to lesson 3-5 from pages 120 to 123. Now boys and girls, we have 6 different examples to get through, so this video will go by quite quickly. I will rush through it. Remember, you can always pause, rewind, and watch things again. We're going to work on adding and subtracting like fractions. When they mean like fractions, they're talking about the denominators are like, meaning we don't have to look for a common denominator, so it makes it a lot simpler. But we will be working with positive and negative numbers, so integers. We're going to work with rational numbers. Okay. A key concept to look at. Oh well, here we have what we will learn. Add rational numbers with common denominators, okay, like fractions. Subtract rational numbers with common denominators. So we're adding and we're subtracting rational numbers. Now let's take a look here at this key concept. To add fractions with like denominators, add the numerators and write the sum over the denominator. Simple. So you don't change the denominator, we're just going to add the numerators, as we know before. A plus B equals A plus B, but we keep C. See, C doesn't change, where C does not equal 0. C cannot equal 0 because then the entire expression, numerical expression, would equal 0. And here's we replace the variables, and here we have 2 plus 3 over 8, right? We keep the 8 never changes, and it's 2 plus 3, and it's 5 eighths. You see that? Okay? 2 eighths plus 3 eighths equals 5 eighths, as you can see, from 0. Here we have a couple of examples where we're asked to estimate. Now, boys and girls, here we have 7 tenths plus 6 tenths. Now, this is just over half, remember. Is this going to give you more than a whole? Of course it will, because here we only need 3 more. Sorry, let me zoom that in so you can see it better. Here we only need 3 more to have a whole, to have 10 over 10, right? And then we're going to have 3 over, so it should be a whole plus 0.3. You could say that's definitely more than a whole. So when they tell us to estimate, they're telling us that we're estimating a whole plus a half. Because, yeah, when we look here, this one is closer to a whole and this one's closer to a half. So they're saying that our estimate should be about 1.5, as you can see right there. Okay? It's always good to estimate to make sure that you're doing the work correctly. Okay, let's try examples 1a to 1d. So we're starting with basic 5 6 over 4 6. As mentioned earlier, you're just going to keep the denominator the same. So we can go ahead and start with that. The denominator will be the same. It's 6. Right? And then 5 plus 4 is 9. But we have an improper fraction, so we must change that. How many 6's? How many 6's are 9? We have 1. What do you have left over on the top? You have 3 left over 6. And you know that this is a half. 3 is half of 6. So you rewrite the whole equation as 1 and 1/2. And there you have it. Okay, let's jump right to C actually, since it's right here. Same thing. We keep the 5, the denominator, and then we do 1 plus 4 is 5. And that's a whole. 5 over 5 is a whole, right? 5 divided by 5 is 1. And now we have a negative. Now we're working with a negative. Don't panic. It's just the way it was before with our negative and positive rule when we were working with integers. But now we keep the denominator the same. We have 7. And now we have a 4, and then we spend 6 or $4, and then we spend $6. We're going to have negative 2, right? Positive 4 plus a negative 6 is a negative 2. Now you can put the negative on the top, or you can rewrite the whole thing as negative 2 over 7, right? Okay, let's try D. 1D. Our denominator is 8. We just keep it right there. It's nice when you have the like denominators, okay, or the common denominator already determined for you. We have a negative 5 plus 11. What is the difference between these two? Okay, from a negative 5, and you add 11 to it, you have a positive 6. But this can be simplified, boys and girls. Don't just leave it as that. You can see that they're both multiples of 2. So here we have 3 2's, and on the bottom we have 4 2's. So you simplify it to 3/4. Example 2, we're going to now add mixed numbers. Okay? For the mixed numbers, these ones, again, we have like denominators. This is rare, but it's nice to have that. And it makes it easier to work. If you didn't have like denominators, if you didn't have these like denominators or common denominators, you would have to change it to an improper fraction, and then look for a common denominator and work from there. But because you do, you can simply take the 2 and the 3 and you use the commutative property and put them together to add it to 5. So you know you have the 5. And then you just work separately with the fraction. With the 3/8 and the 7/8, you work separately with them. Solve that, and then you can put them back together, as you see there. They want us to estimate 2 and 3/8. Yeah, this is less than a half here, so this is closer to 2 if I were to round to the nearest whole. So this is 2. And this is almost a whole here, so this rounds up to 4. So 2 plus 4 is 6. So our answer should be close to 6, or 6. Okay, here we go. And that's how they do it. Remember, you can't leave it as an improper fraction. Here you have more than a whole with 2 left over at the top, so it's 5 and 2/8. And then when you simplify it, you divide them both by 2, and you have 1 1/4. So you see that? So 6 1/4 is about 6. So now let's try 2A, 2B, and 2C. Please, boys and girls, pause the video now. Pause it and try these 3 on your own. Okay, I'm going to go ahead and keep working through it, but please pause now. Pause. All right, first let's estimate. We have 1 3/4, which could be rounded up to 2. So we have, this could be 2 right here, and 4 3/4 is also almost 5. So our answer should be about 7, but it's definitely got to be less than 7 because I rounded up here and I rounded up, right? Okay, let's actually really work with it. I'm going to take, because I have common denominators, I can take the 1 and I can take the 4 and keep those together. Use commutative property, 1 and 4. Okay, and then I'm going to add my 3/4 and my 3/4, right? From each one, the ones I have right here, this one and this one. And now I have over here, I have my 5 plus 3/4 plus 3/4 is 6/4, which tells me I have a whole one here. So I'm going to take this whole one and add it here. So that makes it 6. And what do I have left over? I have plus 2/4, right? And then that's 6 1/2, right? 6 1/2, because this is a half. Right? And there you have it. Okay, again for 2B, I'm going to estimate. I have just less than half, so I'm going to round this down to 3 and this down to 8. And so I have about 11 1/2 is what it's my, because these two should make up another half. So my estimate is going to be about 11 1/2. Okay, let's hope I get that. Again, I have the common denominator, so I can just do 8 plus 3 is 11. Okay, 8 plus 3 or 3 plus 8 is 11. And now I'm going to add the 2/5 plus 1/5. Okay, and that will give me 11 3/5. So I was right, about 11 1/2, close. And now I'm adding a negative plus a negative. Remember, that's only going to make it a larger negative. Okay, it's just going down further. So negative 2 plus negative 4 is a negative 6, right? Going to give me a negative 6 right there. That's an equal sign. Negative 6 plus 3/7 and 5/7, right? Equals negative 6 8/7. So it's going to be negative 7, right? 1/7 when I change it. Don't forget, I have more than 7/7. I have 8/7. So I'm going to take that 7/7, which is a whole, and add it to this amount, which makes it 7, negative 7. Right? And what do I have left over here after I take away the 7/7? I only have 1 left, right? Because 8 minus 7 is 1. So I have 1 left, and there you go. So just a reminder of the key concept that we looked at earlier, to subtract fractions with like denominators, as we have here, okay, the 9 and 9. Subtract the numerators and write the difference over the denominator. So we're just subtracting. I have 4, I'm going to subtract, and then 4 minus 3 is 1, and I keep the same denominator, so it's 1/9. So this will give me 1/9. Here's a nice little reminder to always estimate. So we have a half minus 1 is going to take away this half, right? As you see here, this is about a half, almost. It is almost about a whole. So I should have a negative number because this number is larger than this number. But by how much? Yeah, about a negative half I should have. Okay, let's try it. So here we go. Let's try these 3. Now, boys and girls, here we have 5 over 15 minus 10, 15. Now, this number is clearly larger than this number, right? So what happens then is that you know you're going to have a negative number because you're taking away more than what you actually have. You're going below 0, okay? But look at this. They're all multiples of 5. Why not just simplify? Let's simplify first. Okay, I have 1 5 here. I have 2 5s there. I have 3 5s there and 3 5s there. So my denominator is 3. So I'm just going to go ahead and work with 3 right off the bat. Okay, and now I have 1 minus 2. Right? 1 minus 2 equals negative 1, doesn't it? Because I took away more than I have. So it's negative 1/3. It's a simple way to do it. Again, here we can't do the same on this side. We cannot do because this is not a multiple of 3. Had it been 6 or 9, then we could do it. Here we're taking away 1 more than what we have here. So clearly we're going to have a negative 1, right? Negative 1. Right? And then we just keep our 9. Quite simple, right? Negative 1 over 9, or negative 1/9. This time we're not taking away more than what we have, so we can just simply subtract. We have 8, right? 8 is our denominator, and then 7 minus 3 is 4, right? And that's a half, you know that, right? Because 4 is half of 8. They're both multiples of 4. For example 4, we're going to be working with algebraic expressions, where we can substitute or replace the variable x and y with these values, as you see right there, x minus y. We replace them and we work right through. Okay, and remember the denominator is still the same. And you can see here, okay, how it works on the line, where we're taking away a negative. Now, negative minus, when we have a negative followed by another negative, some of you remember you can just multiply these two negatives together and you have a positive value. Or when you have a number and you're taking away a negative, you're actually adding to it because you're taking away possible negatives, right? And that's how it works. Okay, so it becomes plus 3 plus 4 is 7. You can see here 3 plus 4. Okay. Oh, but again, we're talking about fifths. Okay, we're not. So as you can see, 3/5. This is a whole, which is cut up in 5 parts. Okay, so 3/5 plus 4/5 is going to equal to 1 and 2/5. You see that? So 1 and 2/5. So let's try for A to C by replacing these variables with these values. Now please go ahead, pause the video and try this on your own. Pause it now. Here's our first one. I replaced the variable A minus B, right? A is 3/8 and B is negative 5/8, but it's minus this value. So minus, that becomes positive. Okay, so I can go right ahead and start writing 3/8 plus 5/8. And when I add those two up, I get 8 over 8, which equals 1. Okay, I replaced the variable again, B with negative 5/8 and C with 7/8, as you can see, and it's subtracting. So I have negative 5 minus 7. Negative 5 minus 7 is going to be negative 12. Okay, minus 7, negative 5 over 8. So when I simplify that, how many 8s do I have in 12? I have 1, and then I have 4 left over 8. Now don't forget all this expression is negative, so it's negative 1.5, right? Plus 4 over 8 is a half. Let's try 4C. Let's check it actually, because you should have done it by now. Okay, when I replace the variables, I have C right there, which you can see it's 7/8 minus A, which is 3/8. Now boys and girls, if you're not pausing the video and trying this on your own, you're only doing yourself a disservice. You're not helping yourself. Remember that. If you're not pausing the video, you're not helping yourself for the test. Please challenge yourself. 7 minus 3 is 4 over 8, which equals a half. Okay? I really do hope you are pausing the video and trying it on your own, because then you're not really helping yourself for the test. Okay, example 5, we have a word problem. LaShawn has 5 1/8 yards of ribbon to border scrapbook pages. If she uses 1 7/8 yards on one page, how much ribbon is left? So they're saying she has this much and she subtracts this much from it. How much does she have left? Clearly we are subtracting, as you can see. Just follow the step process, okay? You estimate it first, and then you can just work directly. You can separate the whole numbers, but you cannot. Now this is something I really want you to make sure that you take note of. You cannot separate the whole numbers when the fraction of the second number is greater than the fraction of the first number. because you have to borrow from this number. So what you need to do then is change this